All right, let's put what we know about graphing together to graph some more complex trig functions. So make sure you've watched the previous video on graphing the parent functions, and you've also done the Khan Academy lessons, which will help you tie all of this together. So if you read the instructions, we have to find the amplitude period, the vertical shift, which I would call the midline, and then sketch the graph. All right, so let's do exactly that. The amplitude, well, that's just the number in front of the function. It's what you've multiplied by. In Algebra 2 graphing, this would be the vertical stretch. Now, if this number was -3, the amplitude we would still say is 3, because amplitude is a measurement. All right, I'm going to do the vertical shift next. I'm going to skip the period for a moment. Now, I would call the vertical shift, where's the midline? And that's simply the number at the end. So we have y equals -1 as our midline. And now for the period. Well, the period of the sine function, just the parent function, is 2 pi. To find the period, whatever number is in front of the variable, in this case 4, you divide by that number. So the period is pi over 2. So the entire period has shrunk down to pi over 2. Now, what I like to do, if you go back to the previous video, you can cut one period of the sinusoidal functions into 4 pieces. So the sine function, let me just illustrate what I'm talking about here. The sine function starts on its midline. It goes up to its maximum, so that's part 1. Then it comes back down to the midline, that's part 2. Goes to the minimum, that's part 3. And then returns to the midline again, that's part 4. So one period you divide into 4 pieces. So if I take the period pi over 2 and I divide this, multiply by 1/4, into 4 pieces, that means that every time you go a distance of pi over 8, you're going to go from one of these interesting features to the next. So if we start at 0, and we'll do this on the graph itself in a moment, this first maximum is going to be at pi over 8, and then pi over 8 plus pi over 8, well, that's 2 pi over 8. That means this interesting feature is at pi over 4, and then this one is at 3 pi over 8, add another pi over 8, and then finally 3 pi over 8 plus one more pi over 8, that's 4 pi over 8, and guess what? We ended with one complete period. Okay, so let's do this on the graph. Now our grid lines don't let us go to a resolution of pi over 8, so we'll do the best that we can. So the sine function starts at 0. So we're going to end one period at pi over 2. So this entire sinusoid we have to squeeze into this little bit. So it's going to be hard for me to do on my little writing tablet here. So every pi over 8 is half of one of these squares. And I just realized I forgot about the midline, so I got a little bit ahead of myself. Sorry about that. All right, let's draw our midline at -1. So we'll draw a midline here at -1, and I'm only going to graph one period, so that's enough. If your penmanship isn't very good, like mine, especially with a writing tablet, you can draw 2 other little dotted lines based on your amplitude. So since my amplitude is 3, I can start at my midline and go up 1, 2, 3. So I know I'm not going to cross over this little line at the top, start at the midline and go down 3, and this is where I am. So now we can sketch the graph. Okay, so the sine function, as we were saying, starts on its midline, and the period is pi over 2, so we're going to end back on the midline. Half of one of these squares is pi over 8, so we're going to go up to the maximum, back down to the midline, and to the minimum. Now it's going to be really hard to graph this since the period is really shortened, so I'll do the best that I can. This really should be a nice curve. That's about the best I can probably do. You could draw more periods if you needed to, but this will do for that. So that's how you graph the sine function. It's also how you graph the cosine function. So we're going to go ahead and do that, but I am going to go just a little bit faster for the cosine function. But it's the same thing. All right. The amplitude is a half, and since there's two halves here, it's that one. It's the one in front. The midline is at -1 again. The period of cosine is 2 pi. The number in front of theta, you want to interpret that as 1/2 times theta, so you're dividing by a half, meaning the period is 4 pi. Now, what I like to do is take the period, divide by 4, and this is going to be the distance between interesting features on the graph of cosine. So have a mental image in mind of what cosine looks like. It starts at a maximum, goes to the midline, minimum, midline, back to the maximum. Watch the previous video on graphing the parent functions. So the parent function of cosine looks something like that. So I'm going to draw that same picture, but it's going to be stretched out a distance of 4 pi, since the period is now 4 pi. So sketch your midline. Now the amplitude is really small here. It's only a half, so I'm not going to draw a little horizontal line up a half and down a half, because the picture would look really squashed. So I'm going to go ahead and now draw the graph. So the cosine function starts on a maximum. So here's the midline, and the amplitude is a half, so I'm going to go up a half. Now the distance between the first two interesting features, so from the maximum to where we intersect the midline, remember that's 1/4 of the period, which in this case is pi. So at pi, we're going to be at the midline. Go another pi, we're going to be at the minimum. Go another pi, we're going to be at the midline again. And the squares don't go over, but I can ballpark about where it's at. We'd be back at the maximum at 4 pi. Oh, and I went a little too high. The amplitude's only a half. So draw this the best that you can. And there's your cosine graph. All right, let's do one more. We'll graph tangent. Now a tangent, I'm only really interested in changing the period. You can change, you can do a vertical shift, you can do some other things, but the changing the period is the most important one, so I want to focus on that. All right, so if you watch the previous video, the period of the normal tangent function is not 2 pi, it's pi. So you take the period and you divide by whatever number's in front of the variable. So the period is going to be pi over 2. So how does that help us graph? Well, you really have to watch the prior video. So in short, the parent function of tangent has period pi, and you visualize the first period from -pi over 2 to +pi over 2. So that's where the first two asymptotes are. And then the shape of the graph looks like that. And the important part is that this is one period. Between the asymptotes is one period of your tangent function. Well, we're going to do exactly the same thing, except one period of our function isn't pi, it's pi over 2. So the asymptotes, we're going to have one asymptote to the left of the y-axis, and we're going to have one asymptote to the left. So one to the left, one to the right, and the total distance has to be pi over 2. That means that I'm going to have asymptotes at pi over 4. Now, if you don't see why, I'll tie it together in just a moment. This is pi over 4. And this is -pi over 4. Pi over 4 and -pi over 4 is where I have my asymptotes. Why is that? Because the distance between the asymptotes, that's one period. And we know that the period has to be pi over 2. And pi over 4 plus pi over 4 is pi over 2. So, I can draw the graph. I don't worry about where the x-intercept is at, because the x-intercept is halfway between the asymptotes. Now, if I wanted to graph another period, it would be very easy to do. We're sitting at pi over 4. That's where this asymptote is, pi over 4. If you add another period, well, pi over 4 plus pi over 2, that's 3 pi over 4. And that would be right here. Since we have this grid, you could also just count the number of squares. It's 2 squares between the asymptotes. But if you're drawing this graph yourself and you don't have squares to count, you'd have to do a little bit of arithmetic. Draw the basic shape, and there's the graph of tangent. If you want the graph of cotangent, you have to go through the same thought process, but the asymptotes are in different places because the cotangent function is cosine over sine. Anyway, that's the basics of making some changes to the graphs of sine, cosine, and tangent.